I'm really happy to be here with you all. I have a question for you. What can you learn from next token prediction? So the next token is one idea. There's also some ideas floating around that you can somehow construct an entire model of the world, right? People have different intuitions for this stuff, but it's not really formal. But actually, we can formalize this. And we do this, and we can provide an answer to this question of what models learn when we train them on next token prediction. So that's what I'm excited to share with you today. So let's start with a just simple toy example. So here's a 3-state hidden Markov model. You don't actually get to see the states, you just get to see the data. And so what do you build up? What's your internal representation? Well, if you had something like a world model, you'd think maybe you figure out something like this thing has 3 states, there's some transition probabilities, right? Well, not quite. Actually, we work through the theory, and we instead expect that the model should learn something like this kind of crazy fractal. Why? Well, because we're training the model to predict rather than to generate, and that's a drastically different task, and in fact, you need more than a model of the world to be able to do that task well. And so we expect this sort of structure, and in fact, we expect something like this to just appear conveniently in the residual stream. So what do? We train a model on this example data, and indeed, over the course of training, this fractal is linearly represented there in the residual stream. So we can say we actually know what it's learning and can detect it there. So hopefully you're motivated to understand a little bit of the theory. What angle are we coming at? Basically, we treat a sequence of tokens as a sequence of correlated random variables. And then what can we do with that? Well, we acknowledge that to do as well as possible at next token prediction implies the ability to predict the entire future as well as possible. And then we consider the metadynamics of prediction. So as you move through context and observe more symbols, how does your distribution over the entire future change? All right. So here's another simple example, some 3-state hidden Markov model. It's just 0, 1, random, pretty simple. Any distribution over the states of this model imply a distribution over all possible futures. So as you observe more context, you're going to shift between different distributions. That's the point on the bottom middle. And actually, there's a geometry also to these belief states because they can all be embedded in the probability simplex of the generator. Okay, so this is actually the thing that we expect is this geometric representation of the entire future, not just the next token. And so there's kind of this schematic up top which says, okay, you have all these activations, and just a linear projection should give this thing. And on the bottom, there's this fun example, this random XOR process. There's no pairwise correlation whatsoever, but the bottom middle shows a linear projection of these belief states. And indeed, that's what we find inside of the model. And I think it's important to recognize that these different belief states, many of them have the exact same next token prediction, the same exact probability over the next token, but the model differentiates them as the theory predicts. So finally, this tells us not just about internal representations, but also the behavior of models, that because it's not just generating, that it's predicting, models will synchronize to you in context. Right? And in fact, we can anticipate analytically in some toy cases the convergence of synchronization. I plot here the next token entropy with increasing context, and models will converge to you. And so we find this framework really powerful. There's still a lot left to do. So we've created this new research organization, Simplex, as a house to do that. Really look forward to talking with you all. Our paper on this just came out on arXiv today, so check it out and talk to me on Thursday.